So we are done with CDC part and SQL read and write, where you can have a variety for reading and writing as well with different use cases. And as I said, try to go through the exercise. And if you have any blocker or any issue, we can discuss that. We can have a session properly over there with all the blockers and all what are the challenges you are facing, and then we can go through that. We can try to resolve. Next, we are going to discuss Kafka. Okay. How many of you have heard about Kafka or have an overview at high level with Kafka, what it is and what we do with this? Anyone has any idea about it? No? Okay. So here I have captured over the slides. If you see, okay. So Kafka is a kind of tool. This is also open source tool. Okay. So Kafka is a distributed event streaming platform which is designed for handling real-time data feeds. So let's say you are having data which you want to process on your own pace. Or maybe business requirement is not looking for the data as soon as possible, or you are processing the historical data. In that case, Kafka is not required. This is not meant for that because you are having multiple different things for that. If you are working with Hadoop, then even you can, if that is a simple data migration or data ingestion from Hadoop, maybe one tool to another tool or database to Hadoop, you can use. In Hadoop, we have a scope where you can, let's say you are having some 5-year data into the database. You want to process to Hadoop. You can integrate that data. You can migrate from Hadoop to your from database to Hadoop using scope. If you are working with some other, let's say you are getting some data from some portal, some websites and all, but you are not looking for the uh, data which should be processed as soon as possible it is coming. You are just having some buffer time. You are having some space. So again, you can plan for batching, or maybe some data you are doing the ingestion using REST API or maybe some other uh, alternative option, and that data you are dumping either as a file to the NAS mount location or maybe some other location. If you're working with the cloud, then S3, ADLS, or maybe your HDFS, that can be an option where you are storing the file, or maybe simply file is getting dumped to some other location from where you are going to process. So there you are having some options that okay, this is the file I got it to the source and I have to process that. You can process on your own, maybe to, immediately you can process, or you can process after 2 hours. Or there is a condition that okay, you are getting the data previous day data you are getting today, then again you are not getting the real time data, that also you can process with some space. Or maybe sometime we are getting data maybe after 1 hour interval, like in 24 hour you are getting the source data kind of 10 times or 20 times or maybe 24 times at 1 hour interval with some amount, means all data altogether it is not coming, but it is coming in a way that you have some space. And again business is asking that okay, you are getting the data, you can deliver this data by the end of the day, but they're not saying that immediately I need the data. So in that case, you are having multiple options. But what if business is saying that I am having the requirement that I need this data immediately to be processed, or it has to be managed in the way that it can store the data also, it can take care for multiple things for publishing and subscribing. We can have multiple publisher subscriber and we want to process with the streaming real time and real for the real time analytics, then Kafka is the best option. I am not okay, I will not say the best only because we are having again multiple alternatives for the Kafka, but still I can say that this is the good one. I even what good one? It is the best one only. Which one you can? If you are working with on-premise, then you can utilize Kafka for the real-time analytics. And if you are working with cloud, then cloud is having their own, but they have adapted Kafka model somehow in their different tools, and you can enable that tool with Kafka. Means they have Kafka is a third party which is outside that is getting supported with on-premise also and cloud also, but it is available with the cloud. You can enable your system. Like if I talk about Azure, Then you are having Azure Event Hubs. You can enable Azure Event Hubs with Kafka also, and you can work with this. Likewise, in AWS also you can enable and you can work with Kafka. So you are having the option. Okay. Like yesterday, I had given example, maybe yesterday or day before that, that let's say that you are having commercial websites. Let's say, for example, you are having Amazon, AWS, and AWS means Amazon shopping for the shopping platform, right? And you are having Flipkart, one of the another shopping platform where you are going to do some shoppings. So that is the kind of real time data where you do not want any delay. You do not want something to be taking much time because you want to serve your customer quickly. How if they are looking for a product, you are immediately good to suggest another product. You are immediately doing all the things like let's say uh, if they are ordering, then about their billings and all also that should be very quick. Recommendation should be very quick. Suggestion should be whatever suggestion for the product and product should be related. If someone is looking for electronic items, you are not going to suggest them clothes. You are going to suggest the same related gadgets. If someone is looking for the kitchen appliance, you are not going to suggest them office things, right? If someone is looking for the clothes, you are not going to suggest them shoes. So that's the different. Business has to understand, and accordingly, business should work. And if it is working in the same way, and they are having the limitation for the time, then only they are in the good model. Otherwise, there is something which is lacking, and that is uh, making down the business. That's not good. So whenever we are having batch kind of requirement, then we have more option. One option is SQL also. Yesterday we seen about SQL. Let's say you are having some 5 years of data and that is not yet migrated to Hadoop side, means big data engineering side. Now the requirement is to process that data. And you are getting the requirement, okay, this is the 5 years of data and we have to migrate that to data engineering. And then we want to do some analytics or maybe we want to build a dashboard on top of that after some aggregation, transformation, or maybe some other business requirement. What you are going to plan? You are having 5 years data. Just assume that if 1 year data is 1 terabyte, then 5 year data is 5 terabyte. What you will plan? You will plan that okay, 5 terabyte altogether I cannot process, or if something is happening, then I have to reprocess all the data again. So that's not a good practice. Let's separate the data. So for that you can plan, okay, every day I can process around 10 GB data or 100 GB data accordingly. Let's say 100 GB data. So you can have the application, you can make the setups and all, and you can plan for every day processing 100 GB data. Then in 10 days you will be good with the 100 into 100. You can just calculate and then you can do the calculation that okay, if I am having total 5 terabyte of data, then how many days, weeks, or month this is going to take. Then finally you are done with your task, but you did not did over the real time. But again, what if you are getting the real time? Let's say some customer support, some chats and all, right? Customer support, or maybe you are working for the uh, this commercial platforms, websites and all, or maybe some user interaction apps are there where you are working. In that case, you need the real time data and you are going to serve them. Let's say for the banking and financial, where it is generating the OTP. OTP should be the real time. If you are sending the OTP after 5 minutes, what is the use? It should be very quick. As soon as user is trying to log in, OTP should be sent immediately. If something fraud things are happening, they should be getting alert mail immediately. It should not take lots of time. Even it should be happening within millisecond, not even seconds. Okay, that's the good model. So for that, we are having the option with Kafka. We can go for the real-time analytics. Kafka is the good option. Here, we can have again two options. Two types of jobs are there. One is, let me note down here. One is completely, let's not talk about Kafka. If you are talking about the job, then you are having batch, you are having near real time, and you are having real time. Okay, batch means what? You have the time, you are not in hurry to process, you have just a schedule that okay, I am getting the data from the source and my data will be coming 12 p.m. every day or 12 a.m. every day. Then at the end, by the end of the day, I have to process the data. So okay, let's schedule my job at 2 p.m. kind of that. Or you can say that okay, I am getting some 100 GB of data and at one shot this is not good. So let's schedule that whatever data is coming to the source, let it come, and then I will be processing some data with different schedules. So let's say you can say okay, after each 3 hour. Okay, after each 3 hour means what? This will be running 8 times if you are running for 24 hours, right? Or you can say between 6 a.m. to 6 p.m. You want to avoid night time. So if in daytime some failure is happening, someone from the team can take care or have a look quickly if possible. Otherwise, next day we can have a look. So this is kind of your batch requirement where you are getting the data from the source either at a single as a single or maybe uh, in a bunch with different time. Near real time where data is coming in real time only, but this is not actual real time. Means let's say you are getting the data and you are getting the data by 12 and you are processing by 12:05, means just little bit delay, but if little bit delay also this is having some space, right? So this is near real time. Or you are getting the data let's say every time you are getting the data and data count is something 10,000 for each batch, around 10,000. In streaming, it will never be constant kind of that if you are working accordingly. Then let's say you are getting this much data, but your application is not performing well with 10K. So what you can do, you can say that, okay, I will be running with the batch. So that will be micro batch. So for that micro batch, I will open my window for, okay, 2 seconds for 2K records. That means my window will be working for 2 seconds. That means for if first it will open and it will pick up two K records and it will process, and until unless this is getting processed, this window is kind of shut down, you can say. This is not going to pick another batch. And once after 2 seconds is done, then again it will pick the next batch 4K. That means this 10K data will get processed in 5 times, and 2 seconds means 10 seconds. So that is real time only, but this is taking little bit time. You are managing in a way. That's why this is near real time and micro batches. This is working in the micro batches. This is the complete batch. So people may ask you what kind of data you are processing, whether this is real time or near real time. So you can talk about near real time also. That data you are processing with some delay because of this region. If there is any millisecond delay also, that is the micro batching. If there is no millisecond delay, as soon as data is coming, it should be processed without any handling or without any taking care that okay, for each 2 seconds you will be processing this much record. These kind of limitations should not be there. If that is getting 10K records, let's process 10K. If that is getting 20K records, then let's process 20K. Okay. So like that, if you are having no foundation and no restriction, then that is the real time data. So both you can work with Kafka. Kafka is good to support both the things with the Spark. Even batch also you can work with Kafka. There is nothing that you cannot work. But for batch we have another options as well which you can take care. And this Kafka is good for real time analytics, real time data processing. So here if you come, this is the Kafka. And for this Kafka, what is Kafka? Very first. So Kafka is a kind of distributed event streaming platform which is designed for handling real-time data feeds, and this is widely used for high throughput, fault tolerant, and scalable messaging systems. That is making it ideal for event-driven architecture, real-time analytics, and data pipelines. So here, if you see, this is a kind of platform which is which is for distributed streaming process, and it is a publish subscribe messaging system. That means you can publish the data and someone can subscribe the same. Okay, which let exchanging of data between the application, because of course someone is pushing the data to the Kafka and someone is reading the data to the Kafka. Let's say some producer is there. That producer is producing the source data to the Kafka topic. And then you are a developer and you are a subscriber. You are subscribing the data, or you are processing the data, and you are having some hundreds of the customers. They are working with that application. So they are subscribing the data. They are getting that. Okay, what is there? What is keep on happening? Whatever you are pushing to the system. So this is working with a publisher and subscriber model. uh, it is a publish and subscribe messaging system which let exchanging of data between the applications, servers, and processors as well. So Apache Kafka was originally developed by LinkedIn, okay, and later it was donated to the Apache Software Foundation. So now it's open source. Currently, it is maintained by Confluent under Apache Software Foundation, and Apache Kafka has resolved the lethargic trouble of data communication between a sender and a receiver. So the thing is, you are having the sender, you are having the receiver. Let's say you are working for any other source, some website or maybe some portal, some applications, which is generating the data, and that data you look for your analytics, you for your use case. That data is keep on coming to the Kafka topic, and then you as a subscriber is subscribing the data. So this is something which is working well with the model for the data communication between the sender and the receiver. Then if we talk about this introduction to Kafka. So Kafka is a distributed streaming platform, as I already said, that let you publish, subscribe, store, process, and streams of data in the real time. Okay. Publish and subscribe in the sense simply you can understand. This is someone, let's say some website. This is sending the data. Sending the data. That means what? This is publish, right? This is publishing the data. Then this is Kafka topic. Kafka topic, and then you are the person who is reading the data. That is wrong. Subscribe. Subscribe the data. You are the user. Or here we can say, okay, you are the developer, you are going to get the data from the Kafka topic. So someone is sending the data to the Kafka topic, that is the publish action. Action will be public. Then data is coming here. Okay. This is having data is stored here. Data is stored to topic. And then this subscribing model, who is the subscriber? Let's say you are a developer, then you are subscribing the data. That means you are reading the data. Reading the data from Kafka topic. Okay. So like that, Kafka is having pub sub model for publishing and subscribing. Okay, and then Kafka provides high throughput and low latency for real-time processing of large stream of data. If whenever you have very small data set, I always say this, you will not face any challenge. Everything will be good. But as soon as data volume will increase, your problem will start it. And that you have to take care. So with Kafka or maybe any other system, if you are having some MB of data or maybe few GB of data, of course, that will be working well with the rough program also, rough coding also, nothing to take care. But as soon as that 1 GB will be converting to some 50 GB and 100 GB, then challenges will be there. if either this is taking care everything properly or not. So Kafka is designed in a way where it is having low latency and real for the real time processing and large stream of data. If you have good amount of data where large streamings are happening with the source data, Kafka is perfect for that, and there without any issue this will be working properly. Then Kafka is used in system requiring reliable event streaming such as log aggregation, event sourcing, and real-time analytics. So most of the time when you are having some event data where event is keep on generating at the source, then this Kafka is good because as soon as some events are happening or some changes are in events, that's good to process with your model, capture in the Kafka topic, and then subscriber can subscribe the data immediately. Whenever you have the logs, and on that logs you want to do some aggregation in the real time, then Kafka is a good option. And real time analytics for any of the application where for the data you want to keep on processing as soon as possible it is happening for any of the event. That means your job will never sleep, your job will never terminated, your job should run 24 by 7, either it is having data or not. If it is not having the data, then it will be okay, it will be just checking. You can make a setup that okay, check the data. If there is no volume, then have a sleep for 5 seconds or 10 seconds if you want to do some kind of optimization, otherwise keep on running. And if for any critical application, even we can't make our application to sleep, let's keep on running, either that there is the data or not. And as soon as even a single record will be picked up, then your application will process the data. So for any real-time analytics, this is good. Kafka is highly scalable, fault tolerant, and can handle large volume of data. It is scalable because it is also following the cluster model for the master slave where you are having multi nodes, multiple nodes are there, which we say like which is the terms of the brokers, and fault tolerant because this also supports a replica. Like if you are having the data, it will be maintaining a copy of data. So if it is maintaining the copy, then if somehow if there is any a node failure or some other because of some networking issue, it is not good to communicate, your system is not able to communicate, then it will be working with the uh, another copy. So if something is down or any broker is down, then it will be working with another broker. So for that purpose, it is having a fault tolerant and which is making sure that you are not losing any data at any moment. And it can handle large volume of data. As I said, it is good to handle any amount of data. So whenever we have a really good amount of data with the real time to process, Kafka is a good option. And nowadays, either you are working with on-premise or cloud, if you are going for the interview, most of the time people ask you, okay, what kind of processing you have worked on, or what was your use case with this PySpark. So if your processing type each coming that what kind of works you have did, you can talk about. I have worked with batch data processing also. I have worked with real-time data processing also. Whenever it is coming to batch, you can talk about databases, some other NoSQL, SQL, or maybe even Kafka as well. And when it is coming to real-time data analytics, then you can talk about Kafka. That okay, Kafka was the tool for building the data pipeline, and with that we worked with the processing. So this is the thing. Then Kafka is highly scalable and fault tolerant is the main thing, which is making it more better. Okay, that this is making sure that you are not going to lose any data. Then, if we talk about its architecture, so here Kafka is having some parts like we had in Spark. We had nodes, right? Master node, then worker node, executors, and all. Here also you are having a Kafka cluster, means again group of machines, right? So if we are talking about Hadoop clusters or Spark, then we are having group of machines. Here Kafka clusters means again this is also grouping only. So a cluster contains multiple Kafka brokers. You are having multiple brokers, and Kafka brokers stores data and serve clients. Whatever data we have, that is going to be stored with the Kafka brokers. Like you can just relate with your Hadoop and Spark. Then topic. Topic is the main thing in Kafka. where your all the data is going to be stored. So Kafka messages are organized into topics which are split into the partitions. So whatever data you are getting from the source, that data will be stored in the topic. And then partition. So partition is the part of topic. A partition is an ordered, immutable, and sequence of messages. So we'll talk about this after this slide. Topic and partition. Okay. Then producer. Producer is a producer sends messages to the Kafka topic. Who is pushing the data to Kafka topic? That is producer. And who is reading the data from the Kafka topic? That is consumer. So consumer consumes the data from Kafka topic. And there you have zookeeper. So Kafka relies on zookeeper for distributed coordination, keeping track of the brokers and consumers. You can say kind of master or who is keep on monitoring that okay everything is working well or something is down or if this Kafka broker is down then what should be the next kind of that. But again everything all the systems are keep on updating, right? So this Kafka is also having enhancement and then role of zookeeper has been changed with the latest version. Now let's talk about this Kafka architecture. This is the same where you have producer. Producer is pushing the message and these are the consumer group A, group B. And here you have consumer 1, consumer 2, consumer 3. You can have multiple consumer. You can have multiple producer. And this is sending the data and this is reading the data. So this is one person. Just I'm assuming consumer group A is the one person. Okay. And then consumer group B is the second person. They are just reading the data. In between, you have data. This is the Kafka cluster where there is zookeeper which keep on playing its role. And here you have broker. This is the Kafka cluster, and where you have broker 1, broker 2, broker 3. So broker 1, broker 2, broker 3, which is you keep on managing all over the data and all. Okay. So if something is coming for the Kafka, so as a developer point, we are not diving into how internally or backend it has been defined or it is working. We are just responsible for reading and writing the data. As a developer front, I am talking about. So if you anytime if you are getting this thing in your interview, then you can talk about what you did with Kafka. You can explain your work and then you can explain about the architecture. In architecture, yeah, you may get question around this. A Kafka cluster, so brokers, what is broker, what is zookeeper, what is consumer, what is producer, what is consumer group. So these are the main things. What is publishing and subscribing. So question 90% of the questions will be around this only. And when we talk about this zookeeper, then if I talk about the older version, okay, as I said, for any of the tech stacks, there will be some enhancement. These are keep on updating with each of the version. For PySpark only, PySpark means let's talk about a Spark because PySpark, just because we are using that with Python. So if we look at Spark, then just to compare the initial version and nowadays what we have, there is a thousand times differences. Lots of differences are there, and even in the next 1 hour or two, 1 year or 2 year there can be many more changes, many more new enhancement. Okay. uh, and maybe they can have some more enablement, more API support and all, and they can have some more advanced levels because we are getting multiple things, multiple new tech stacks using our Gen AI, OpenAI, ChatGPT, and many more, right? So the, of course that those are going to be parts. So always we are keep on learning, keep on continuing with the enhancements and all. Like that in Kafka also, it had the zookeeper. So in the previous version, it was responsible for managing metadata, leader election, and broker coordination. However, with Kafka, I guess that right now this is having around 3. Okay, so Kafka 2.8 and later, Kafka have craft. Okay, we say, let me write it here. that is craft. K-R-A-F-T. Craft. Craft. That means Kafka Raft. So that is the short for Kafka Raft mode for the replacing for the zookeeper. So, if we talk about the previous version, then it was working for the metadata management, leader election. Leader election means in the sense if this is having a leader which is working for with the main thing. If any broker fail, then zookeeper will help to elect a new leader. That okay, now you are the leader and you have to take care. Then broker coordination, consumer group management, all the things we are taking care. Then Kafka craft mode each came with the 2.8 2.8, yeah, and then and Kafka 3 dot version, whatever is the latest version. So now craft is working, but again question is why this removed the zookeeper, because zookeeper is a nice tool and we are not going to do anything with the development, and zookeeper is not only in Kafka only. This is in most of the applications. In Hadoop also we are having zookeeper, right? And in multiple, if you are working with HBase and all, there also you are having zookeeper. So why Kafka is removing zookeeper? That is having the point that it is for reducing the complexity. So Kafka is no longer depends upon the external system, because zookeeper is the different service which is enabled with the Kafka, and Kafka is working with that. That means it is having dependency. So just to remove the dependency. Then faster metadata management. So as Craft is the internal integrated with Kafka itself, that is not the external. So this is storing metadata directly in the Kafka brokers. Then Kafka can handle more partitions per cluster if there is no zookeeper limitations. And then fault tolerant also, that is the main property of Kafka. Kafka owns raft based consensus protocol which is more efficient. So these are the things which we are going to work with that. And if we talk about Kafka latest version, that as I am saying that after 2.8 zookeeper is removed with craft, then I guess Kafka is running with the 3. Okay. Kafka 3 point star, you can say, where it I guess it should be around 3.9 version. Okay, maybe it can have more than that as well, but I did not check to that, so I need to confirm. Then let's come back here. Anyone has any question here with the Kafka architecture? From anyone? Nothing? Okay, so for Kafka architecture, you can have this in mind that you are having a model of Kafka cluster where you have publisher. You have 3 terms mainly. You have publisher, that is means producer, that is producing the data. You are having the consumer, that is consuming the data. So one thing is producer, second is consumer for read and write, and in between your data is stored, and that is stored with the brokers, and multiple brokers will be there. And if you group the brokers, that is uh, treated as a Kafka cluster. Okay, so group of brokers are the Kafka cluster, and to the Kafka cluster your data is stored, and then publisher can publish the data and subscriber can subscribe the data from these topics, and these topics are stored with the brokers itself. Okay, I think this is a duplicate slide. I need to delete it. Okay, so here you are having Kafka producer. Producer is responsible for sending data to Kafka topics, and producers can publish messages to specific topics and partitions. And producer APIs allow you to send messages synchronously or asynchronously. Kafka Producer is highly configurable, allowing you to define properties like compression, partitioning, and acknowledgement strategies. And one thing I will say in data engineering, everything is configurable. 100% I can't say, but 98% I can say that whatever you want, as per your own wish, you can go to the properties and you can change that. Even if you want to do the change, make the changes globally, you can do that directly with the config file, but that is not recommended because that is going to impact all the users. And again, as a developer, we will never be having the access to do that. That is under control of admin team. So as a developer, for our particular application, we can do with the command line. But everything is possible what we can. And if something is not available with the command line, you can request with the admin that this is required and why you need it. If you are having valid reason and if you are good to explain and make them understanding for the region you want to have the changes, of course they will do that if that is the demand. Otherwise, they're going to deny simply. Then Kafka consumer. So Kafka consumer is responsible for reading the data from Kafka topics, and Kafka consumers can work in consumer groups to scale processing across multiple instances. And consumer tracks offsets which are pointers to the last processed record in a partition. And then the Kafka Consumer API allow users to configure the message retrieval strategy. Okay, so like that, this is going to work. And then you have topics and partitions. So topic, a logical channel to which record are sent. Topics are divided into the partition. If we talk about partitions, then Kafka partitioning allow scaling data is distributed across multiple brokers to balance the load. And when we talk about replication, then Kafka allow each partition to be replicated across different brokers for fault tolerant. Let me come to the topic here. Let's say someone is pushing the data. That data is something 10 GB. Then you will be having a Kafka topic. That means you are having the broker, you are having the architecture, means a Kafka cluster, which is a group of brokers, and inside the brokers, your topic is getting managed. But at the high level, you are not going to see that, right? That is just a configuration, that is a setup. But your main point is topic, where this 10 GB data is getting going to be stored, and then you are running a PySpark application, PySpark application to read data from Kafka topic. This is what you are going to do. Okay, so you are having a Kafka topic, and to that Kafka topic, you are going to store the data. You can have multiple topics. Let's say you are having customer data, finance data, some other commercial data, and then you are having some chat data, okay, customer related, some incident, some different incidents are keep on generating, some different logs are there with different systems. So you can have multiple varieties of data, and for all varieties of data you can have different topic. Let's say you have some let's say let's take example of banking system only. You are having some finance data, some for that banking, you are having some wealth management, you are having some insurance, if you that, let's say ICICI bank or SBI bank, they are having their insurance terms, right? So some other team is working over there, so that data is also coming. Or maybe related to the customer addresses, customer passbooks, customer debit and credit. You are having different. All the data is not going to be stored in the same topic. Maybe for the customer, it can be the different. For finance, it can be different. For wealth management, it can be different. For consumers and all, it can be different. So let's say you are having some four kind of source data, and that four kind of data is going to be stored in the four Kafka topics. So here we can say topic 1, then topic 2, and topic 3, and topic 4. Okay, you have 4 kind of data. So let's say this is your consumer data, banking consumer. Let's take it finance, make it simple. And this is your customer related data. This is your logs, some customer chat support. Here you have some transaction logs. Okay, some different data are there. These data are going to be stored into the different topic, because no benefit of keeping all together. For this one, of course, there should be different teams. Different teams will be there who is taking care of that. Some different team is there who is taking care of that. And if same team also, then they are not going to process all data together. There is a different purpose for the data, so they will be processing parallelly. This is going to be processed as a separate pipeline, this is going to be processed as a separate pipeline, because of the different use case and types. So let's say you are having topic 1, topic 2, topic 3, topic 4, where your source systems are publishing the data to this topic. Now topic will be having the partitions. Okay, so let's take the example of topic 1. You can have partition 1, then partition 2, partition 3, partition 4. You can have n number of partition. Okay, let me copy this for all. So let's take it for Kafka topic 2, and then Kafka topic 3, and then take for Kafka topic 4. What do you see here? You are having maybe here I can say partition 5, means there can be different number. Okay, partition 5. Here I can say it is having more partitions. So let's say fill in the blanks and then come to partition 10. Okay, so this is having 10 partitions. So different number of partition can be there. So you can have multiple topic, inside each multiple topic there can be multiple partition. This partition is going to help for parallelism. Parallelism in the sense, let's say you are working with PySpark. PySpark is having 10 executors. That means you are working with some, simply you have allocated 10 resources, 10 executors, and you have repartitioned the data with 10. So each executor means each worker node is processing some amount of data. Here, if that is reading the data from a topic and topic is having single partition, then only one executor will be engaging here and remaining will be sitting idle, right? Because this is having only one thing, only one partition. So one executor will be getting the data, and then you have to repartition the data again to make sure that all the executors, all the resources are getting the data to process. Keep on working in parallel mode. Here, if you have multiple partition, then let's say you are having 4 executor in the Spark, you have, and you have made 4 repartition, then you can make a 4 partition in Kafka topic also. Then without any dependency, they can work, one resource can pull data from here, one resource can pull data from here. So parallelism will be more. Here you can achieve full parallelism, and that will be more better, more faster. Okay, because of that, based upon the data volume, based upon the requirement, we can plan for the number of partition. Of course, we should not go with so many partition. We should have a limit, but you can set up and you can go for a standard number like 10, 20, something. Again, based upon the data. And what Kafka does, let's say this finance data. Source from source data is coming to the topic 1. So Kafka will be trying to distribute the data between the partitions. By default, if you have let's assume that from the producer side you have set up some logic, how it should be distributed, then it is fine. But if you are going with the Kafka, means a Kafka default one, you are not doing any additional code and all, you are just relying over the Kafka. Then Kafka will be trying to distribute the data equally within the partition, but always this will not be completely 100% equal. Let's say you have 100 record, so 25 record can be there. 20, expected is all the four should have 25 records. Kafka will try for that, but maybe it can have 25, it can have 28, it can have something 22, it can have remaining. So something here and there can be, but it will try to make sure that okay, these are having at least an around equal data, so there will not be kind of burden, overburden, that this is having more data, this is having less data. Then already we discussed this problem, skewed data skewness, right, in Spark, how it behaves very badly if someone is having overload and someone is having no load, means very less data. So that is a challenge. That challenge is everywhere in all the terms. So we have to always take care of that. That no one is going to be overburdened with the data and no one is having kind of very less data and it is sitting idle. Now data is coming from the source. That data is getting divided into partition. So topic name will be unique. Here you can see, right? If you will be creating a duplicate topic, it will be giving you error that this topic already exists. Topic name should be unique. Partition. For partition, you are not going to give any name. You are just going to say how many partition. Partition 1. Now let's say how this is going to store the data. So let's say you are having some 20 records in the topic. So this will be storing the data in terms of offset. Offset is the simple indexing, you can say. Okay, indexing starts from 0. That means let's say I am having 20 records. For that 20, I am going to have 1, 2, 3, 4 in 4 terms. Just give me 1 minute, okay? Okay, so let's assume that I am having total 20 record. Total 20 records. Okay, that is what I'm getting from the source. So in partition 1, this is going to store as offset 0. That means I'm just writing the offset, indexing is 0 only. Okay, offset you will not be seeing, but let's assume this is 0, and then you will be getting 1, then 2, and 3, and 4. Then it's the turn for partition 2. So for partition 2, it is 0 again, then 1, 2, 3, and 4. Similarly, this is going to be for these as well. Where is 0? It should have 0 as well. Okay, 0 is here. That's wrong. And now again this one. So what do you see here? All the data, just I'm assuming that Kafka divided equally. So this is having 1, 2, 3, 4, 5. This is also having 5, 5, 5. So offset starts from 0. This is just indexing, okay? Because based upon the offset only Kafka works with the data. And if you see, topic, if you have multiple topic, that will be having unique name. Partitions, this will be having different means n number of partition can be there inside each of the topic, and data will be distributed between the between the partitions, and that will be having its indexing, that's called offset. Okay, and offsets start from 0, and offsets are not unique for the topic. That means yeah, so if you look at this offset 0 is not unique for the topic, because 0 is the offset in partition 1 also, 0 in partition 2 also, partition 3 and partition 4, right? But this is unique for this partition, means offsets are unique at the partition level and not at the topic level. You are getting the point? You have to understand it properly, because these are the things kind of means this should be very clear. You should have proper understanding with this, because this is not very complex. You have to just make your understanding with the topic, with the partition, with the offsets, because Kafka is playing around with this only.
Like for the offset, can you repeat once?
Okay, so in Kafka, you have a Kafka cluster. In that Kafka cluster, you can have multiple topic, because there can be multiple producer, multiple kind of data is there. So all kind of data, if you want to push in a single topic, you can, but no need, no benefit, right? So we can segregate the data. That okay, this is the transaction data, keep a separate topic. This is the finance, keep the separate topic. So you can have different n number of topic that will be unique. Now each topic can have multiple partition, that you have to decide how many partition you want. Based upon the data volume, you can plan. Let's say one of the topic is getting data something 1 GB only. Then one partition or two partition is enough, right? No need to go with the 20 partition and multiple partition. And some data, let's say some this transaction log, this is getting 100 GB every day, then 100 GB is a good amount, then you can go for 10 partition, 20%, 20 partition accordingly. You can plan out for that. So you can have a number of partition that you will be deciding whenever you are creating the topic. Then data will be divided, means the data is getting distributed between the amongst these topics. If you have 1, 2, 3, 4, so amongst all four topics, data will be distributed. Kafka will try to divide the data, distribute the data equally, but always it can't make sure 100%. Like here I have given example that for 20 I just made 5 5 5 5, but maybe in real time it can have 6, it can have 3, it can have 5, means something here and there near about it can have. Okay, total count will be 20. Now how this will be storing the data? So all the partitions are going to get some records, means all 20 records get splitted between the partition, that is going to be stored with offset. Means that simply indexing. Kafka is understanding, okay, I am receiving 5 records, so let's make indexing. Indexing 0, 1, 2, 3, 4. This is starting from 0. Again, partition 2. Kafka is topic is thinking, okay. Again, for this also, let's make me have a clear indexing 0, 1, 2, 3, 4. And accordingly, this will be storing the offset. So offset is unique for the partition, but not for the topic, because offset 0 is in partition 1 also, and offset 0 is in partition 2 also, and offset 0 is in 3 also, and offset 0 is in 4 also. Okay, and accordingly data is distributed. Okay, so accordingly this will be distributed. Did you get the point for the offset?
Yeah.
Okay, now when we talk about this, Then we are going to read the data. So let's say producer produced the data here. Producer produced the data to the Kafka topic. And on the top of Kafka topic, we are going to have all these terms. Now, uh, as a consumer, we are going to consume the data. Okay. So let's say we are consuming the data. So as a consumer, we are consuming the data. So for this consuming, there can be a requirement that all data I am reading at the same time, like 0, 1, 2, 3, 4, 0, 1, 2, 3. For whatever I have, I just read that. Or maybe I can plan to read in batch. Here we previously we talked about micro batches, right? Micro batches means all the data I am not able to read at a single time, same time, because of maybe we can have multiple limitations. So what I am as a consumer, I am just planning 10 records. Okay, I am planning to read 10 records. For 10 records, what will happen? I will be reading from partition 1. From partition 1, I am going to read. Just I am making it readable for you so you can have understanding. At any point, if you not have, please stop me. I am going to read 0 and 1 and 2. Okay. So this is my 1, and again I have 2. This is not a syntax, just I am writing for you. You don't think that you in real time you will be getting like this comma and numbers. 3, and then partition 4. So this is your partition 4. Like that you are going to get. So just assume that I read 10 records. So 3, 3 and 2, 3, 3, 6, 2, 8 and 2, 10. So from third one and fourth one, I read 2, 2 records, and from first and second, I read 3, 3 records. Next time, again, I will be reading the data from Kafka. Then it is a challenge. How Kafka will understand that whatever you have already read and what you want to read, or you want to process duplicate data, or you want to process unique data only. So if Kafka is not having understanding, then next time when I will be trying to read, again this will be giving me same set of record, right? But Kafka is more advanced. Kafka is more intelligent, I can say. It is designed in a way that lots of things we are not going to cover with our own coding. Means it is good if you can handle with your own coding, but not required. Kafka is enough to understand and handle that. So Kafka will be understanding. Kafka will be, you are going to read with the group ID. Group ID. So let's say my group ID is ABC. I am just giving a name ABC. So with this group ID, it will be understanding that, okay, uh, it will be treating this one as a user. Okay, this is a group ID and this has already read 3 from here, 3 from second, 2 from third and 2 from fourth. Next time when ABC is requesting for the data, again 10 records, then Kafka has saving offset management. Means this offset saving management. Whatever offset you have already read, Kafka will save this. Kafka will say that, okay, you have already read it. So next time I am not going to repeat the same data until unless you request for this. Okay, either you read from beginning. If you are saying read from beginning, then it will be again starting from the beginning. But if you are not going to do that, then Kafka is enough mature to understand that understand this. Kafka will simply save the offsets internally without any additional mechanism, without any additional handling. And when next time again this job will be running with same group ID ABC, then it will provide the data differently now. It will say, okay, last time you have read this and again you are requesting for the 10, then this is the output. 10 records again ABC is requesting, then this will be giving 0, 1, 2, 3 and 4, right? Because this was pending. From 2, again this will be giving 3 and 4. And from third one, this is going to give 2 and 3 and 4. And for fourth one also 2 and 3 and 4. And this will be offset. Offsets will be saved by Kafka automatically. Same will be happening here also. Offsets will be saved. Offsets will be saved by Kafka. Okay, so offset is safe here. Here also offset is safe. That means now it is understanding that okay, you have already read 10 records and 10 records in the next term. Again, this ABC is trying to read the data. What you were expecting? Tell me, as per your understanding, what you are going to get this time. What Kafka will publish? Any idea? So Kafka saved here 10. For 10 records, again Kafka did the offset saving. Next time there is no offset left, right? So this will be having 0 record. If you are trying to read, you will be getting 0 record because you have already read all the data. Or if any new data has inserted in this offset, that you will be reading, but it will not repeat the same. Okay, but again, let's say that you did something wrong. Whatever you processed with ABC, there was some issues, and you want to reprocess the data. Reprocess the data means Kafka has already set the offset, then it is not going to give you the data again. Either you can start from beginning or simply change the group ID. Okay. So here you have group ID ABC. So for ABC, Kafka understand that I have already saved. Now you change the name, make it XYZ. If you are saying XYZ, then Kafka will understand that okay, XYZ is a new group ID. And I have not saved anything for this group. Okay, then let's start from beginning. Again, it will start from 0, 1, 2, 0, 1, 2 and all. Like that we work in the real time. Like let's say finance data is there. Finance data is getting some 10 columns, 20 columns. And you and me and some other, we three are there and we are working with the same data. But business use case is different. For you, it's different. For me, it's different. And for another, it is different. Then of course we are going to work in the different terms with different application. You are reading the data, same data. I am also reading the same data. But if offset savings will be happening, then it will be disturbing to another people, right? If you are working and you have saved the offset, then for me, I will be getting the next data. Then I will be losing the previous data, which is already saved. So what we can do better? For the same data, you can have a group ID ABC. I can have group ID XYZ. Another people can have MNOP, something else. So if we have group ID different group ID, then offset savings will be happening for the group IDs, means a group ID level. So this is not going to impact another user. For you, maybe you if you have 10 records, if you have read 10 records, then for you 10 offset has been saved. If I read if I have read 2 records only, for me only 2 records has been saved, 2 offset has been saved, and next time I am good to read another remaining 18 and you will be reading only 10 because you have already read 10 records and that is saved for you. So here lots of questions will be around the Kafka. If Kafka is coming to your interview part, that's why I was trying to make you understand that you have understanding, and if you have any question just let me know. So there, if it is coming to the interview, then there can be okay about the Kafka architecture. There you can detailed about the Kafka broker, that you have the brokers, and group of brokers is the Kafka cluster where your data is getting managed, data and metadata, and data is getting managed in terms of topic, because topic is a unit which is storing the data. You can have multiple producer, you can have multiple consumer. Producers are producing the data to Kafka topic, and consumers are consuming the data, means reading the data from Kafka topic. Each of the topic we can create a number of partitions. Okay, and in each partition we will be having offsets. Data will get distributed amongst the partitions, and data will be having unique offsets, and that uniqueness is partition level and not the topic level, because same offset can be part of another partition as well. Like here we can see 1 2 3 4, right? Same you can have here also in topic 2 also. Now while reading the data, when consumer is trying to read the data for same topic, we can have multiple consumer. So let's say here Suleiman is reading, so for Suleiman this is XYZ, and Om Prakash is trying to read, for him group ID is ABC. So for different terms will be there. For him, whatever is saved, that is not saved for this ABC also. So group ID means simply it is treating as a different user. So offset savings will be happening based upon the group ID, and that is a automated system by Kafka, where you are not going to do any additional code. You are not going to take care. Kafka will be taking care of it. But we should take care of it. If possible, we can have our own design, we can have our own coding to save the offsets and for reprocessing, because by default, what will happen? Whatever already saved, next time this will be reading next data. Next means if it has read up to 2, then next time it will try to read offset number 3 if that is not read, if that is not saved. That is how it is going to work. But Kafka is having retention period. Retention period can be from millisecond to it, you can set up for the weeks or a month or year. So most of the time in real time, if you see, it is set up like 1 week or 1 month. In rare cases, it can be for 3 months, but not required, because why you want to store the data unnecessarily? Once we process the data, then we can clean up the topic, but we keep the data in topic for some time, because maybe you want to reprocess the data or something happened wrong, that is not meeting the expectation. So if you will delete the data immediately from the topic, then again you have to pull the data from producer, right? So that's not a good thing. You can keep data here for some time, either 1 week, 1 month, or whatever is your plan. And if something goes wrong in your processing, again you can revise your processing. You can edit the data again. For that reason, Kafka is having retention period, and that is again configurable. You can set up the time how long you want to retain the data in the topic. After that, automatically data will get deleted. Here is the challenge. As Kafka is having retention period, let's say today my job is going to run at 2 p.m. and let's say my Kafka topic is having retention of 7 days. Okay, today uh, 7 days is getting over, and today my job did not get run somehow. Maybe it was not uh, running properly, or maybe some networking issue, or my server was down, cluster was down, something happened, and my job did not run, and it had to run. And today itself, the retention period is going to be over. Then tomorrow my job will be running, and it will be getting that okay, there is no record because records has been deleted. What will happen? Each Kafka is going to remind you that records has been deleted and you are losing the data? No, Kafka will not say, because Kafka is simply understanding that okay, by default I am saving the offsets. So next time, whatever is available with me, I will give to you. So if it is having the data, it will give. It is not having. If data is deleted, it will simply say zero record. So if retention period is over, it will be. sending zero records, you will be getting null. Okay. So in that case, you are going to lose the data. And even this is not notifying you that from offset number this to this, you had not processed and this has been deleted because retention period is over. So in that case, what is the solution? Because you can have multiple data pipelines, and for each of the pipeline, you cannot remember always that whatever you have processed and what is yet to process. That has to be managed by application and all, right? So there you can have manual setups. You can have some manual logics and all. So what you can do, you can say, okay, this time I have processed these many offsets simply. So let's save it somewhere. Let's say save it to a location for next run reference. Okay. And next time when your job is starting, then it will be looking out for that. So I simply saved it. Next time when my job will start, then I have set up a logic that, okay, you check that offset number one. Each having 0, 1, 2, then you have to read from 3. Third one, from offset number 2, you have read from 2 and you have to read from 3. So your job will be checking, okay, I want to read offset number 3. I want to read offset number 2 for the third partition. If it is over in the retention period, if it is deleted, then simply your Kafka job will fail. Kafka job will say that this is not available or this offset is missing. This offset is missing means you can get the problem. Okay, we have missed the data because of retention period, data has been deleted. Then you can plan to reprocess the data. That how you will be managing the data from the producer, and again you will be getting the data. Or if you have backup somewhere, then from backup you will be reprocessing the data to make sure that you are not losing anything. Otherwise, if you are going with the auto management with the Kafka, then you may lose the data. That can be a condition, like just I gave the example. In case of something happened wrong with the jobs and all, it did not run, and in between, retention period is over. So that can be one of the challenge. And again, this is not required for streaming and all, because streaming anyway that is going to work 24/7. As soon as data is picked up, then immediately this will be processed. So there is no chance that you are losing the data because of retention period, because minimum, let's say you are keeping retention period for 1 week, but in real time analytics you are processing the data as soon as it is coming. So if you are processing with micro batch also, and you are having some delay, let's say you are opening a window for 2 seconds or 5 seconds. So 2 seconds and 5 seconds are okay. You are having 1 week retention period. So anyway, that is not going to cross until unless your application did not run for a week. Somehow it was completely stuck. Then you will be losing the data. So either that is if that is streaming one, then that's better. Always not required to handle, because Kafka is going to take care and you have enough time. Data will be available with the topics. But still, you can have your own logic. You can have your own mechanism to save the offsets and make sure that if because of retention period, if any data is deleted, then your job is getting failed and you are getting notified that this data has been deleted. And that is again part of critical things. Some kind of data is there where if you lose a single record also, that's a concern, you should reprocess. So in that case you can have this mechanism. Some data are there, okay, if you lose something doesn't matter, let's process whatever is available, forget about the previous data. In that case, no need to handle anything, because you are not going to take care of that. Let's say some loggers, some log data is there. So you that is not more important, okay, because you are not having any critical delivery on top of that. So whatever is available, let's process over that only. If something is loose in between because of retention period and all, let's forget. So this is again depends upon the data criticality and its importance, what is the use case and where you are going to use, and what is the um, kind of priority for the data delivery and all. Accordingly, you can have the plan for mechanism and your logic requirements and all. Any question here? I will just say one line that if you are good with the Kafka understanding, this is a small topic. Means as a developer point, you are not going to have multiple things. You have to just think about this topic. So let me go to the slide and uh, this one. Kafka cluster means a group of brokers. Topic. Inside topic, you will be having offsets. Then partition. Sorry, inside topic you are having partitions and inside partitions you are having offsets. Then producer and consumer and zookeeper. And consumer is consuming the data with group ID. Here you have where you have producer which is pushing the data. These are the brokers. They are this is the consumer and consumer is reading the data with consumer group. That I gave the example of ABC and XYZ. That consumer group means Kafka offset management savings will be happening based upon the consumer group. For consumer group, the offset will be saved how much it has been read, and for consumer group B, offset savings will be different. If it is reading two records only, for this only two will be saved. If it is reading some many records, maybe 10, 20, whatever, then that many will be going to the savings. Offset savings will be happening accordingly. So you can have a different multiple consumer group and offset saving mechanism will be happening based upon the consumer group only. And I understand that you are having proper understanding now with offsets. Offset is just indexing for the data, and with that data is keep on storing inside the partitions. And I can say that if you are having a clear understanding with producer, consumer, broker, partitions, offsets, and group ID, then you can uh, answer all the questions related to Kafka. Almost all the questions you are going to explain nicely, and that is going to have a positive impact if you are good to explain along with the project use case. Okay, and I can give example. In one of the product-based company, my selection was, I can say that I had gone through multiple questions with different things, including Java, Spark, Hadoop, and all. But center point for my selection was Kafka, and because of this kind of explanation, okay, means they had asked about it architecture and all, and I discussed in detail about the partitions, its offsets, how it's managed, how it is getting stored, and that was the point where they get more impressed that okay, I have a very deep knowledge, and that was the decision point for my hiring. That was a good company, good brand, good salary, everything was fine. So we don't know which point is going to be a game changer for you. Any point if you get, you can plan to explain that nicely, and that can be a game changer really. People can have an impact that okay, you are having very deep knowledge, you are having very deep understanding, then let's go ahead. So that is the thing. So you can take it, and this is really useful because all the time in all the projects, in most of the projects, I can say not all the project, but in most of the project we are having the requirement for the batch and streaming, both both kind of data. Are you good with it or any question? No question? I guess that you people have understand very well. Is it? Then I can ask the question. Can I go ahead? Don't worry, I'm not going to ask. Okay, but the thing is, you should be having a proper understanding. And at any case, if you feel that we should repeat, please let me know. I am always good to do that. Okay, because whatever you are getting, you should be having confidence over there. Not require that you are knowing 10 things and you are not having confidence over a single thing also. That's bad. If you are getting 10 things, then at least Uh, Out of 10, at least 2 to 3 should have proper confidence. 2 to 3 should have average. And 2 to 3 you can go, okay, I know this at the basic level and all. If this is the ratio, then also you are good. But no confidence with anyone, no average with anyone, then that's bad. You should not be basic for everyone. Basic should be with someone. Someone can be average, someone can be excellent. So you can divide the tech stacks accordingly. That which one I am going to take for the excellence level, which one I am going to take. Okay, if I know this much also, this is fine. Okay, then are you good with this or not? Let me know. Just let me know.
Yeah, Anamika, I understood.
Yes.
Okay, then before moving to next, I will just repeat one more time. Here we have Kafka producer we were talking about here, right? So it is having major components as we see. If you looked into this one, then you can have some producer, consumer, broker, zookeeper, and all. So here, if we talk about producer, then it generates and publishes message to the Kafka topic. This is the main property of this. This write data in an append only model, no overwrite. Okay, but that is the default nature. Again, if you want to overwrite only, you go with the backend code or you write your own producer code and then you run accordingly. Then of course this will be happening. But if you're going with the default one, then this is going to write the data in append only manner. And this supports batching, compression, and asynchronous processing. Then you have topics here. If we come here, then we have topics. Topic is the logical storage unit where messages are categorized. As I said, this is a unit where data is going to be stored, and if you have different kind of data, then you can categorize the data, and for each of the category you can have different topics, and then you can produce the data. Okay, this is the finance data. Let's put in the finance topic. This is the logs, then put in the logs topic like that. So you can segregate the data, you can categorize, and you can push the data. Topics are partitioned for scalability and parallel processing. As I said, you can have a number of partition, but you should always plan that I am not going with unnecessary number of partition, because let's say you are getting 100 records only in a day and you made 20 partition. Is that a good idea? To getting five records. Five records means again a small kind of distribution is there, right? Not good. For 100 records, even single topic is enough, or maximum 2 topics you can plan. But what is the benefit of having 10 partition, 20 partition? But if you are having some thousand, millions, billions of records, then of course you should plan for the number of partition. And according to the number of partition, if you are working with the PySpark, then you can plan for the Spark resources as well. And you can have repartitioning for the data as well. And then you can make sure that nothing is going to the waiting list in the queue, and that is working properly. And it is working in a parallel mode, that okay, if Kafka topic is having 10 partition and I am having 10 resources in the Spark, then each resource is reading from each of the partition without any queue, any waiting list or else, right? So accordingly, so it is divided into the partitions, and that partitions are for the mostly for the scalability and for parallel processing. So partitions are going for that. People can ask you the question, how you can make sure that jobs are running parallel with the Kafka topic. You can talk about partition here, that we can decide for the number of partition at how much. Then can be a question, how you will be deciding the number of partition, or how you are going to make it more better with the Spark. Then you can talk about that. That main thing is data volume. You should have proper understanding what is the data volume, what kind of record you are getting, If that is coming with the number of messages, that what can be that number, and then what is the availability for the Spark resource. For that Spark resource, if you, let's say you are having 20 Spark resources available, means you are allocating 20 executors, then accordingly you can partition the Kafka data also with 20 partition. Then you can make sure, okay, this is going to be processed in parallel, one by one, means one on one, and there is no queue, no waiting list and all. So accordingly you can go ahead with the parallel processing. And topics can be configured with retention policies. As I said, topics are having retention policy. Retention policy means how long data will be residing to the Kafka topic, and after that data will get deleted. So it can be, you can set up that, and it can be milliseconds too. You can have weeks, months, 3 months, 6 months, 1 year, whatever. But as a good practice, you can think about up to 1 week to 1 month. In rare case, for very critical data, you can think up to 3 months, because this is going to have the space, right? Let's say you are getting every day 100 GB data. Unnecessarily, you are storing that 100 GB data even after your processing is done. Then is that really needed to keep over the Kafka topic? Because this is going to occupy the space and you have to maintain that. So keep as long as it is really required. After that, it should be deleted. So this is having retention period policy to store the data for a specific period, and you should choose that. So this is also can be the part of question that how long your retention period is. You can talk about that based upon the data, its requirement, its criticality, or some other use cases, maybe for the future use case we do this. And again, along with the retention period, Kafka is having challenge for losing the data. As I gave you the example that Kafka does offset savings automatically once you read the data using group ID. But in between, if retention period is over, data will get deleted. And Kafka will not be sending any notification, or next time this will not throw any error that this data is not available. Kafka will try to read the latest data. Whatever is available, it will try to pull for you. But if you want to make sure that in between, if anything is losing, then I should be notified, then you have to go with your manual implementation. You have to write your own logic that, okay, last time if it is reading, if it read offset number 4, then next time it should read offset number 5 only. If it is not reading 5, then that means I have lose the data. So I should be notified. So this is your manual thing. You have to take care. Kafka will not take care. Kafka will simply say, okay, you already read 4. Kafka is having the detail, and 5, 6, 7 is deleted, and now it is available. That is the new data. Kafka will simply pull it for you. It will not tell that in between 3 you have lose. So that is your thing. That is in your bucket. You have to take care. Based upon the data, based upon the requirement, you can plan either you should handle or you should not. Then we have partition. So topic is a unit where data is getting stored with some specific retention period. Now for the partition, this is a division, subdivision of the topic that allow parallelism. That a partition, a topic data can be divided into multiple partitions, and each partition is ordered, and message inside the partition have a unique offset. Okay, so each partition is ordered, whatever data it is having, and message, whatever message it is having, uh, inside the partition, that will be stored with the offsets. That means in simple term we can say indexing, and that will be always unique. Okay, like 0, 1, 2, 3, this will not be repeated, and this will be unique for partition only and not for topic. That means in a topic you are having 4 partition, so all 4 partition can have same offset. Let's say first offset is 0, so 0 can be in 0 will be the first offset for partition 1 also, and 0 will be first offset for partition 2 also, like that. Then you have brokers. So Kafka servers that stores topic data. Okay, because you are having the topic in as a developer, where you are going to work more, you are going to work with the topic is having the data, and then subscriber and producer. Subscriber in the sense consumer, and then producer is producing the data. So broker is in terms of Kafka server that stores the topic data. Means all the data is getting managed over the Kafka cluster, and Kafka cluster is the group of Kafka broker. So Kafka broker is going to manage all the data, metadata, and all. A cluster consists of multiple brokers, and broker handles read and write request from the consumer and the producer. So if producer is trying to push the data, write the data, then Kafka broker is the one who is handling all the read write request and maintaining everything with the topic. If consumer is trying to read the data, then Kafka is again going to manage read write requests. So for producer and consumer, whatever read write requests are happening, broker is the one who is going to manage everything. Then you are having consumer. Consumer is for reading the data from the Kafka topic. So producer pushing the data to Kafka topic means writing the data to Kafka topic, and consumer reading the data from Kafka topic. Consumers subscribe to topic to process messages asynchronously and works in a consumer group to distribute processing across multiple consumers. Consumer group, I believe that you are having group means you can have multiple consumer groups that is helping you to distribute processing across the multiple consumers, and when you are reading you can have different multiple group id, and based upon the group id offset savings will be happening. Okay, then you have consumer group. So a group of consumer can work together to consume data from the partitions. If you look at here, so this is the consumer group A, this is the consumer group B. So a group of consumer that works together to consume data from the partitions, and each partition is assigned to a single consumer in a group. And this ensures parallel and fault tolerant processing. So you can have the consumer group, you can have multiple group consumers, means a group of consumers. Okay, and then you can have group id. Group id in the sense group id is simply this, that is just for saving the offsets. Like you can have group id abc, you can have group id xyz and all. Then you have zookeeper. As I said, this is the part of previous version and not the latest version, but you should be having proper understanding because zookeeper is a tool which is not only with Kafka, this is with multiple. And again, let's assume that you are going to say that okay, I have experience in Kafka and I have worked for around 2 years. Just assumption. Then it is not always mandatory that you did with the latest version only, right? Maybe you can have um, a task with the previous version, or maybe you are having some 10 years of experience, and out of 10 years of experience you are saying that uh, 2 years back I worked with Kafka. Then 2 years back maybe latest version was not available, that time this version was available. So there should not be any conflict, right? Let's say if I am saying I am having 10 years of experience in big data, and I say that I have not worked with Hadoop. Is that possible? No, not possible. Because that time Hadoop was there in the market. Spark was very less. It was just an initial phase. So by time to time, my experience should be sync. It should be match. Whatever we are saying, that should be compatible with each and everything. So if you were talking about I worked with 3 years, 4 years back and all, I am working for last 5 years, then last 5 years was not having the recent version. That time the older version was running. And then you have to talk about according to the older version only. If you are saying that okay, I am having only 2 years of experience and I am working recently over there with the project, then you talk about the latest version, latest thing, whatever. Don't worry about the previous things because you are having very less experience and you are talking about the recent one. Then why to bother about the previous things and all. So that is the point for the people who are having more experience and they are going to talk about that. Then zookeeper. So zookeeper is for managing metadata, leader election, and broker coordination. That okay, these many brokers are there, and if anyone is down, then how it is going to be up, how it is going to make sure that uh, mm, one is working as a leader, and then another's are follower. Then if someone is down, then how it is going to make another as a leader. So managing the metadata, leader election, and broker coordination, and this is required for Kafka cluster management. So Kafka cluster management is happening via zookeeper only, means you can assume that in a company we have CEO, right, who is taking care of each and everything. Just have a look and make sure that everything is working fine. Even CEO is not a developer, that person is not writing the code, but that person is making sure that all good. So that's what the role of zookeeper. This person is not doing multiple things. Even you are not going to write any code specifically to this, just some configs, but this is going to make sure that all good, everything is fine. If not fine, then what to do? So that's what the point of zookeeper. So this is required for Kafka cluster management. And uh, as I said, this zookeeper is replaced in the latest version with Kafka 2.8 and later to that version. So Kafka has moved to Craft, that is Kafka own mechanism. Because zookeeper is the third party, it is having the dependency. Now Kafka is having no dependency, and this craft was just to remove dependency on the zookeeper. Okay, if we talk about how it works, then producer publish the message, and Kafka distribute message across the partitions using a key. If we are providing the key, we will talk about that practically tomorrow. Then messages are stored persistently based upon the retention policy, and then consumers subscribe to topic and read the message. Kafka allows fault tolerance using the replication. So each partition has a leader and a multiple replica. Okay, that this is the main copy in the sense that's the leader, and then replica. That's where zookeeper play a role. That okay, if broker one is working as a main copy as a leader and another copy is with the broker number two. So if this broker is down, then that means main is down, leader is down. Then what to do? Then let's keep on processing with this without single wait. Means no need to wait because one copy of data is available here also. So zookeeper will understand that okay, this is down, this leader is down, and this is the second copy. Then make it as leader and let it work. So zookeeper will elect this one as a leader, and then processing will keep on happening with this. So Kafka allow fault tolerance using the retention, and partition has a leader and multiple replica. And consumers use offsets to track processed messages. Consumer, you are reading using group by D, and using group by D, it is good to track that how many messages has been processed, because this is having offset management savings, and this is going to understand with that only that how much you have already read and what is the pending to read. Okay, so mostly you have to understand here about its major Kafka features like scalability, fault tolerance, and high throughput and low latency. Its durability and reliability, streaming processing, and use case I can say like log aggregation, real-time analytics, event sourcing, messaging system, data pipeline, and monitoring the metrics and microservices communications, and all multiple things are there where you can use. Okay, even we have multiple ecosystems with Kafka Stream, Kafka Connect, Kafka SQL, and all multiple things are there. So go through this, okay, and have a look over the architecture. Try to understand that mostly about the Kafka cluster, broker, pa- topics, partitions, offsets, consumers, producers, group ID, and all. And if you see any challenges, just let me know. We can discuss about that. Tomorrow, we will be going through the Kafka setup, installation, and practical hands-on exercise. Okay. Any question here or any comment?
No.
Okay. Fine then. Let's meet tomorrow. Have a good day. Bye.
Bye.